Hello everyone, our focus for this video is differentiating polynomials. Now, the derivative of a function tells us the gradient of the function at a point. The derivative of a function f of x is usually denoted by dy by dx or f prime of f of x or y prime. So those mean the derivative of. Now, one of the rules that I am going to teach you is the power rule, right? Let's say if y is equal to x raised to the n, then dy by dx, which is the derivative, is equal to n to the x to the n minus 1. Right? So that's what the derivative, the power rule states, right? So let's look at some example. Example 1. Look at some example. Let's say we have a function and the function is y equal 4 root x, right? And you are asked to differentiate this function. Well, anything that is right as root of something like the square root of x or the square root of y or the square root of 2, then all of this can be rewritten to be x to the half, or this can be y to the half, or this can be 2 to the power to the half. So we can use that knowledge to rewrite this problem to see that this is therefore y is equal to 4x to the half, right? And then now we can differentiate this function using the power rule to see that dy by dx is equal to half times 4 will give us 2x. And then if you subtract a half minus 1 will give you negative a half. And that's how you would differentiate a function using the power rule. So let's look at the next problem. So y is equal to 3x to the 5th power, right? Minus 4x to the negative 3, right? Minus 3x to the negative 1. And you are asked to differentiate this function with respect to x. Then dy by dx is equal to 5 3 is 15, so that is 15x to the 4th. Now, when you differentiate minus 4x to the negative cube there, then negative 3 times negative 4 going to give you plus 12x. Minus 3 minus 1 gives you minus 4. Now again, negative times negative here going to become plus, so this is going to become plus 3x to the minus 2. And that's it. That's how you use the power rule to differentiate polynomials. Alright? Now what we are going to look at in this video is differentiating log function. Right? So let's say if y is equal to ln x, right? Well, let's call this f. Let's say y is equal to ln f. And we want to differentiate this. Then we can say then dy by dx is equal to f prime over f. Right? So that's what this is saying. So that's a rule. You differentiate what is inside of the bracket and then put it back over what is inside of the bracket. So let's look at some example. Let's say example 1. Let's say you have a function y is equal to ln x, right? And you want to find the derivative of this. Then dy by dx is equal to, differentiate x, you get 1, put it back over x. So dy by dx is equal to 1 upon x. Alright, let's look at another one. Let's say I have y is equal to ln 2x squared cubed plus 4 in bracket. Right? I want to differentiate this function. Then dy by dx is equal to, differentiate what's inside of the bracket. So if you differentiate 2x cubed, that gives you 6x squared. Differentiate plus 4, that's just 0. So all of this over 2x cubed plus 4. Let's look at another one. Let's say I have a function which is y equal ln 3x to the 4th power minus 2x to the 3rd power plus x to the squared minus 3x plus 1. All of that. You are asked to differentiate that. Then dy by dx is equal to, you are going to differentiate all of this in the bracket. So if you differentiate 3x to the 4th, that gives you 12x to the 3rd power minus, if you differentiate 2x to the 3rd power, that gives you 6x squared plus, if you differentiate x squared, that gives you 2x. Differentiate minus 3x, that gives you minus 3. Differentiate a constant, that gives you 0. So all of this over all of this in the bracket, which is just 3x to the 4th minus 2x cubed plus x squared minus 3x plus 1. And that's it. So now we are going to focus on differentiating exponential functions, right? So let's say we give it a rule. Let's say I have a function which is y equal to e to the kx, right? And you want to differentiate this function. Then dy by dx is equal to k times e to the kx. That's basically it. So this is the rule that you will use. Now, let's look at an example to make sense of this. Let's say I have a function which is y is equal to e to the x. And you're asked to differentiate this function. Then dy by dx is equal to e to the x. If you differentiate the power, you get 1. And then you just put back the function. Right? So that's basically what this formula is saying. Kx is the power. If you differentiate kx, you get k, and you put back the function. So let's look at another example. Let's say you have a function which is y is equal to 2e to the x plus 1. Right? That's what you have. And you are asked to differentiate that function, then dy by dx is equal to, if you differentiate the power which is x plus 1, that does give you 1. And you multiply that 1 by the function itself. So 1 times 2 times e to the x does give you 1. 2e to the x plus 1. Let's look at another one. Let's say I have y is equal to 2e to the 3x plus 1. And they are asked to differentiate this function. Then dy by dx is equal to, if you differentiate 3x plus 1, that gives you 3. You must take that to multiply the original function, which is 2e to the 3x plus 1. This can be simplified to give dy by dx is equal to 3 2's give you 6 e to the 3x plus 1. That's it. Now let's look at another example. Let's say that you have the function y is equal to a to the sine x. Right? You are asked to differentiate this function, therefore dy by dx is equal to, differentiate sine x, you get cos x. Alright? And you just multiply this by e to the x, which is just e to the sine x. That's it. Let's look at another one. Let's say I have y is equal to 3e to the x to the fourth, right? And you are asked to differentiate this. Then dy by dx is equal to, you differentiate the power, which is x to the fourth. If you differentiate x to the fourth, that will give you 4x to the third, right? So you're going to take 4x to the third to multiply all of this. So it's going to be 4x to the third times 3e to the x to the fourth. Right? Now you can combine this, and all you will get is dy by dx is equal to 4 times 3, that is 12, so that can be 12x to the third e to the x to the fourth. Alright? And that's it. That's how you differentiate an exponential function, right? Thank you for watching, and do enjoy the rest of your day.